Okay, so we are going to work through question 2 here, which says a metal wire rack can hold up to 6 bottles of wine. It has 4 identical vertical legs designed to sit on a shelf, 2 identical straight sides, and 2 identical corrugated, i.e. wavy, sides as shown in the diagram below. So here it is right here. The corrugated side at the front of the rack can be modeled by the function h with the rule, this right here, where h represents the height in centimeters above the shelf at a horizontal distance of x centimeters from the base of the front left leg of the rack. Okay, A, what is the amplitude of function h? It's 1 mark. To find what that is, it's simply going to be the coefficient of cos of pi x on 7 here, which is just going to be 1. So my answer to the very first one is simply going to be, wait for it, 1. Perfect. That's 1 mark right there. Next, how high above the shelf are the tops of the legs on the wine rack? So how high above the shelf are the tops of the legs? So what I'm trying to figure out is this height right here. So what I'm going to do to figure out what this height right here is going to be is give this thing a graph. So I'm going to come over here, I'm going to come here, and I'm going to type in that this is going to be 10 plus cos that, let's put another bracket there, put my pi, multiply that by x, close my bracket, divide it by 7, close my bracket again. That looks good. Hit enter. Let's just double check I put that in correctly. That looks so good. All right, so now let's come up here. This is what it looks like. So now we can kind of just picture what's going on here. This right here is going to be the height of this leg. So if I go menu, analyze, maximum, right there, it's going to be 11. And as you can see, it's worth 1 mark. I just have to put in the answer. How high above? So I'm going to say that it is 11 centimeters. Ready? It just needs the answer, 11 centimeters. Hooray. Next, find the corrugated side at the front of the rack. For the corrugated side at the front of the rack, what is its maximum height in centimeters above the shelf? Okay, so the maximum height, well, it's just going to be 11 again. It's simply going to be 11 because that's going to be 11. This is going to be 11. If we just want to double check that maximum from here to here, it's going to be 11. This is 14 being there, but 11 is your y value. So it's just going to be 11. It's worth 1 mark yet again. So that is what I'm going to say. Another way to think about it is your vertical translation up plus your amplitude, which is 11. 10 plus 1 is 11. Next, the average height in centimeters above the shelf. Well, the average height is going to be my maximum plus my minimum, and then divide that by 2. So I know what my minimum is going to be. It's going to be 10 minus 1, which is 9. But just to prove that to you, there you can see it right there. So now if I go 11 plus 9 and then divide that by 2. So what I'm doing is I'm going 11 plus 9, then I'm dividing that by 2. Well, 11 plus 9 is 20, divided by 2 is going to end up being 10 centimeters. Another way to think about this is simply looking at where you have got that vertical translation, and because you've got that vertical translation at 10, it's obviously going to oscillate around that 10. Let's keep on going. As you can see there, they were only worth 1 mark, so we just needed that one piece of information. Next, what is the horizontal distance in centimeters between the 2 front legs of the wine rack? Okay, so what's the distance from here to here? Okay, to figure that out, what I'm going to say is, we know that this can fit 6 bottles of wine, right? So that means, you know, I'm going to have 1 dip, 2 dip, 3 dips, 4, 5, 6. I have, that's really ugly, but as you can see there, I have like 6 notches, 6 dips where I put my wine bottles. So I've got 6 of them. So if we come over here for a moment where it's probably a bit easier to see, what I'm going to do is I'm going to say I have 1, 2, 3, and I could keep counting until I get to 6, but that's kind of not the greatest way to go about it. The best way to think about this is to say, all right, I know that I can fit 6 bottles of wine between the 2 legs, and I know that I have 6 complete periods between the legs. So if I come down here, I can say I have 6, oh, let's not do this in orange, let's do it in black. I have 6 periods between the legs. if I can figure out what a period is, so remember that's going to be 2 pi over pi on 7. So I'm going to go, it's going to be 2 pi on 7, which is going to end up being 14. And then that's going to be the period. So P is equal to that. So now I'm going to say 6 times 14, which is going to be equal to 84 centimeters, is going to be my answer. Just like that. So that's going to be my distance. Let's get a highlighter and let's highlight that. It's going to be 84 centimeters. Perfect. So that's how you'd go about that. Let's keep on going. What is the domain of H? Well, my domain of H is from 0 to 84. That's pretty easy, is it not? That is really quite easy. So nothing too tricky there at all. So let's just come down here and let's put in that answer. So our answer here is going to be that the domain of H, all right, let's write domain, is going to be, am I going to include 0? I am. And I'm going to include 84 as well. Perfect. That's what it's going to look like. It's only one mark. Let's keep moving. A rectangular piece of stiff, what? Let's read this carefully. A rectangular piece of stiff cardboard sits horizontally on the wine rack, so its two longer edges are parallel to the straight sides of the wine rack. The cardboard sits 10.5 centimeters above the shelf, as shown in the diagram above. Okay. Find the length, Find the length in centimeters of the two shorter sides of the piece of cardboard, correct to 2 decimal places. Okay, so what I'm trying to find is, I'm trying to find that length right there, and obviously that's going to be the same as that there. Whenever we're doing these things, I always do like to start by giving it a graph. So I know that this piece of stiff cardboard is going to sit 10.5 centimeters. So if I come here and I just graph y equals 10.5, you can kind of picture what's going on. I'm having this right here. And now if I can just find my points of intersection, so the intersection from there to there is that, menu, analyze, intersection, here to here, is going to be 11.7. I need to give my answer to 2 decimal places, so I want some more decimals here. Let's just give it a lot more. Oh, that is 11.7. That's as best as we can do it. Okay, so now that we have that piece of information, right, let's just try that again. Are you telling me that that's all the decimal places they have? 6. Okay. Well, what happened to that last time? I hit OK and it didn't work. Whatever. All right, so there you go. Now, to find the distance between these, you would obviously just subtract these values and you would end up with your answer. But as you can see, this is worth 2 marks. So I'm actually going to have to kind of walk through what I've done here. So let's just come here for a moment. Let's come to this. So what I'm doing here is I'm saying, let us solve for when f of this is equal to 10.5 for my x values. That's what I'm doing. Now, do you see how it gives it to me in that form, in which it's a bit of a mess? That's because this thing's going on for infinity. So we want to specify what we're doing it for. So let's just say such that, and we're just going to do it for one period. So let's just say 0 to 14. So 0 is less than x is less than 14. And now that will just give me my 2 right there. So this one and that one. So because this is worth 2 marks, let's just put down that line of working just to show everyone that we know what we're doing. Now this is h of x. So what I'm doing is I'm going h of, let's not do this in red. Let's do it in black. I'm taking h of x and I'm setting it equal to 10.5. And from that, I've discovered that x is going to be equal to 2.3 going on forever. And also x is going to be 11.6 going on forever as well. Now to find the distance, so to find, what do I want to say? Let's just say distance is going to be 11.6 minus 2.3, which is going to be equal to, let me come over here, let me grab this one, let me subtract this one, 9.3333, and I need to round this to how many decimals? 2 decimals, so it's going to be 9.33 centimeters. And that will be my answer. Not too Not too bad. That isn't too bad at all. Let me get my highlighter and highlight that. Okay, let's keep on moving. All right, consider this. All right, so let's just put this into our calculator. So we're saying g of x control this is going to be equal to, now my h of x in my calculator is defined as that, so let's just put that in, then minus 5, and this thing has a domain as well from 0, control that is less than or equal to x, control that is less than or equal to 28. I put that in, it's done, so that means this now corresponds to that. Perfect. If I come now and graph that, g of x is going to give me something that looks like this. So if I can just zoom out here, so you can see exactly what we need to do here by looking at this. And you know, we could go through this like the long way of doing it by hand, but why would you want to if you got your trusty CAS? So now we just need to figure out a few things, such as what is my maximum? Let me just get rid of those. Menu, analyze maximum from there to there. What are my minimums? Analyze minimum from there to there. Analyze minimum from there to there. Also, I need to figure out what this point is here. So if I go g of 0, I'm going to get out 6. All right, so now if I come over here, I can say I'm starting, let me get, and I will do this in blue. I'm starting here, and I'm going down to where I have 7 and 4, and then I'm going to go up to I have 14 and 6, and then I'm going down to 21 and 4, then I'm going up to 28 and 6. Okay, then I have to mark the endpoints, so I have to label this is going to be 0, 6, and this point right here, this point right here is going to be 28 and 6. Instead of actually sketch the graph, mark the endpoints with their coordinates. Okay, so that means, now this is where you need to be neater than me. Drawing on this on a tablet is a bit tricky. That is so bad. So in the actual like year 12 VCAR, they actually care about how you draw these things. It has to be like a bit flatter, and then it has to kind of get a bit flat there. There can't be like any jaggedness to it. This is horrible. You know what I'm trying to draw here. Let's just do it. So I'm letting you know how important this is for you to do properly. It should look something like that, but a lot better. Okay, I think that's everything we have to do for that question. And I think that's it. I think that is it. That is it. Hopefully you found this video helpful in going through this. I will see you in the next video.